Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper extracted from 2019 Time Zone 0 in November. That is first question number 1. Stuff asking on topic 1, stoichiometry, especially testing on the concept about student in knowing the concept of limiting and excess reagents. Let's see. First, 0.10 mole of the hydroxide is now mixed with 0.10 mole also of the calcium carbonate according to the following chemical equation, which is going to be a really classic typical acid reaction that generates salt, water, and CO2, right? And asking which of the following combinations is going to be correct. First of all, testing on whether the student can identify whether the HCl or the CaCO3 is the limiting, and also secondly, the product, which is the yield of the carbon dioxide. First of all, we should be first identifying the limiting reagent, and the technique is basically pretty simple. First, we know that according to the chemical equation, HCl is related to our CaCO3 in terms of the recipe according to the coefficient as illustrated from the balance equation, 2-to-1 ratio. 2-to-1 ratio, right? And then next, what we have now in hand is that given for hydrochloric acid, we have 0.1 moles, so that's how to mark it down, 0.1 moles. And then also we have 0.1 moles of the CaCO3, calcium carbonate, right? And as I always mention in class, right, the technique of finding the limiting or excess reagent is that first of all, we just mask one of the given moles, right? Because too much information for me doesn't really good for us, right? So the first thing that we should do is to mask one of the given mole and then ask ourselves, right, if according to the recipe, so the recipe is the blue area, right, that 2 moles must be reacting with 1 mole, right? So 2-to-1 ratio. And if now you've given me 0.1 for the HCl, so for this logic, isn't it, or for the 2-to-1 ratio, I will need the 0.05 moles of the CaCO3 according to the theoretical recipe. Remember, I always call it as a recipe, like 2 HCl relating to 1 CaCO3. So 0.1 moles of the HCl will now be 2-to-1 ratio, 0.05 moles of CaCO3. Then next, what do? We'll look back to the given CaCO3 and see if we get enough, and you'll find out that in this case, I'm given to be 0.1 moles of CaCO3, and I'm actually theoretically only need 0.05, right? So which is more than enough, right? So that's why for this perspective, first of all, we can already know the CaCO3, which is the one in excess, right? Of course, you can do another way around. So like we can again redo it and mask this number, still the same thing, right? According to the recipe, if I mask the HCl first, given I'm now having 0.1 mole, and by expected number, I will need 1-to-2 ratio, so 0.1 to 0.2. I'll be needing 0.2 moles of the HCl for the complete reaction. And then look back, do I get enough? This time I'm only receiving 0.1, which is not enough, right? So both for the starting, no matter you mask this side or that side, at the end we're still arriving to the concept that the HCl is going to be the limiting reactant, right? So that's why with this perspective, first of all, we can know that the answer can only be A or C. The next thing, right, we should be using the limiting reactants to project any product at the end. So that's why for this case, we should now projecting CO2. And according to the recipe again, the recipe says, right, now we're focusing on HCl and CO2. The coefficient in front of them, which is also 2-to-1. Also in this case, that means the HCl to our CO2, yeah, is also going to be 2-to-1 according to the recipe. And now I'm given the limiting reagent to be 0.1 mole. Mind you that we must use the limiting reagent to project any of the product yield, right? Because the excess is the one that's not going to be consumed totally after the reaction has finished. So that's why using the excess reactant to project will mark a wrong answer, right? So that's why using the limiting reactant, we're now projecting according to the recipe as stated from the given equation 2-to-1. So 0.1 will then be projected with 0.05 moles. So that's how the answer is obvious, right? With 0.05 moles, the answer will then be C for both combinations to be correct.